minutes.
It will not. It's pretty fast.
You're a chronic.
Do you remember what happened last time? Alex, stop talking.
Just give it a sec.
Mr. Cooper, have you been followed by
There it is.
any bots yet?
Okay, so basically what you guys are going to see here, okay, if you look specifically at, and please mute me if you haven't done so already, the My Project Lead the Way, once you guys go in there, you're going to go to 7.1, looks something like this. Now, I've explained this now twice because it seems to sink in a little bit deeper when you guys hear it twice. So the first thing we're going to do, okay, I'm going to talk, oops, didn't put it on the big screen. Yes, sir. Call slips. Okay, thank you. So basically, right from procedure, we're going to talk about what's going to be the project itself first. So what you're going to do, I'm not going to be here on Monday. We talked about that, or I just said that earlier. You need to work on this for the rest of the class today, as well as on Monday when I'm not here. The first thing you're going to do is you are going to look, and you're going to see grid spacing 0.25. You're going to draw this, 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 and this in Fusion as a model. Okay? There's 5 drawings, I believe. 1, 2, 3, 4, 5, 6 drawings. Okay? You draw those in a model. And I'm going to try and just show you guys from the get-go. There we go, wing. So in Fusion, don't see. Don't see. In Fusion, there's some things that we're going to talk about today that I'm going to reference to right now, okay? So the first thing you're going to see is I got this random box, just a random square. So after you draw each of the 6 drawings inside a model, you're going to drop down from Design, you're going to go to Drawing, you're going to go from Design. Now the first thing you got to look at is this stuff here, because this is really relying on how you are going to actually dimension what you need to dimension in the correct format. So if you look back at the actual activity, it says for the first one, spacing 0.25, pretty straightforward. Datum dimensioning and align dimensioning, okay? The next one says, don't worry about that, chain dimensioning with unidirectional dimensioning. All this stuff is foreign to you. I'm going to talk about it all today. Coordinate method with datum dimensioning, angular method, reference dimensions, and then this one we're not doing anything special. You're just going to draw this and dimension it like you see it. Okay? So I'm going to teach you all that today. Now the first thing, I'm going to bring back Fusion in a bit here after I talk about this. The first thing that we're going to talk about in general is basically what this PowerPoint represents. Now this thing, I found out 2 days ago now what's on the test for the EOC. It is hard. Okay? All the stuff I'm going to be talking about in these next 3 presentations, this one included, are all on the exam. Okay, I'm going to break down and tell you guys exactly what's on it later, but for now, let's just talk about dimensioning standards and we'll go from there, okay? So please take these notes, please ask questions, and if I'm going too fast, tell me to slow down. I've tried to slow down in the last couple rounds, but we'll see. Okay, next, here we go. Let's start this. So these are the notes. Let's get the notes out of the way, and then I'm going to show you guys back out where the activity is. All you have to write down here, ANSI is the American National Standards Institute. ISO is the International Organization for Standardization. ANSI, the American National Standard Institute, and that's just for the North America.
The North America.
The North America.
Not the South America.
You made me nervous when you walked in.
Or the Asia, as my daughter says.
ISO is International Organization of Standardization, and that's the worldwide spectrum organization for the standards of engineering. ANSI is just for North America, and ISO is basically for the worldwide, the rest of the world. ANSI is standard, ISO is metric. Why? Because we still don't want to do what everybody else is doing because we're special in every way. America, that's right.
Hey, Mr.
Why
Cupid,
did they
the
mess
amount of
up?
money and the time that it would take to convert everything would be astronomical. So at this point, it's not really worth it, is it?
Yeah, it is.
No, but why did they mess up the initials? It should be IOS. International Organization for Students.
Because that stands for, I looked that up last year, that
Okay.
stands for something,
Okay.
and they couldn't do two.
iOS is the Apple.
Oh, yeah, it is.
There you go. Perfect. Thank you, Alex.
Wow.
That was actually
It's
That's
the
okay.
Apple.
useful. All right, so don't worry about that. Don't worry about that. Okay, these are just review. This just goes through basically what we've already known. Dimensioning text, dimensioning lines, extension lines, arrowhead just to give you guys just a little quick review on what we've done so far. This is just talking about some guidelines. So if you're crammed inside of here and your text is really tight inside of here, you can put it on the outside, and all you got to do is collect that little thing, and I'm going to try and reference as much as I can to this fusion, and I'll go back to this, I guess, in a later date. Let's select ANSME. So after I bring this in, just a quick review on how to do this again. Originally, it'll bring in, or default-wise, it'll bring this open, okay? You come over here, you pick your orientation on which one. You're going to make a multi-view. Okay, you're going to have the one corner. You're going to hit the second button way up here. Sorry, this one. And you're going to see the project. You click once, you drag it up, that's the top view. You drag it over, that's your side view. After you're done with that, you can go into the isometric view, right-click, press OK. Remember, double-click this. It'll bring back open here, and you can do the the pretty view for that side view or the isometric view. Now, obviously, this is a little small, so we can also go into the sheet size. Remember, that's all down here. Sheet size we can make a little smaller if we need to. We can then click once, move these little things around, and they're going to lock everything in. Just a quick review on what we've done already. And then we can remove this. We don't really need this. We can even remove the border if you wanted. But as far as dimensioning is concerned, you click once up here for dimension, and you're going to click each one of these pieces. Now, you can do aligned. Now they've just done this edit. And you can right-click, and now you can say just vertical, where it just aligns with the drawing, which is really nice. You can right-click again, and you can click horizontal, and it'll automatically start detecting the horizontal that are related to those two. It's kind of a nice little feature. Vertical is what I want here. But if you're getting, a little bit crazy as far as alignment, if we go back to this PowerPoint, basically what they're referencing to is here, if it gets crammed in here, you're going to have to put it on the outside. This is what I was just trying to reference to. Horizontal just basically means that this number here is not to the left or to the right, and vertical alignment just means that it's not to the top or to the bottom. It's just right in the center. Fusion, the great thing about Fusion is it auto-aligns for you. So after I press OK and get out of that, if I press this once, I'd have to manually screw it up if I wanted to. It's automatic within the system if you didn't do it by default. Okay. So, great. So you click once, and then in the center, you're going to drag this up, and again, that's default. It's just in the center, so you're straight. If you go back to the PowerPoint, unidirectional align. Rather than going through all those words, the easier way to see is the unidirectional align. So unidirectional is just when all of the dimensions are the exact same orientation. Aligned means that they're aligned with the feature itself. So once we see here, they're aligned. Now the freak out method that people had earlier today is how do I get that to adjust in Fusion? In Inventor, it was really easy. You just right-clicked. The new thing that's going on in Fusion is that you have to go, and once we're in a drawing file, you can't do this while you're in the drawing file. So you have to figure out through the activity what they're asking for before you even start. So if we go back here, for example, and you scroll down and it says align dimensioning, right? Well, align means that it's aligned with the part. So in Fusion, this is not line. This is unidirectional. So how do we change that? You can't change it in the drawing file. You have to do it here, and this is what I didn't explain to the other classes because I forgot. You go to drawing, and then you go to from design. This first thing that pops up, we just talked about ASME and we just talked about ISO. You have to select ISO if you want the aligned feature. Okay, so you have to decide that before we even start actually dimensioning that you want to do that. Then when you select it, and I'll show you what it looks like. Now when we come in here, bless you. Come in here, you change this stuff all the way to the right or whatever it's going to be. I think it's top actually. Yeah. So if I just do this view just for the sake of time, and I come in here now and use the dimensioning tool, oops, you'll see, oops, I'm nervous. I know. And then you do vertical again. Now you'll see that the text is aligned with that system. Okay? So you can't manually rotate that. You can't do anything to fix that. You just have to pre-select ISO over ASME. Okay? Remember, you can always just select the line too. It makes it 10 times easier. You don't have to select those points. I know a billion people are going to forget this too. To do an angle, You select one angle or one line, you select another line, and then you can auto-adjust where you want that angle to go to. People are going to ask me that, I guarantee it. Okay? Questions or concerns so far? Too fast? Too slow? Maybe so? Alright. Let's keep going. So the next one, size and location. These are two classifications of dimensions. So the first one is size. That basically just refers to the size of the feature that you're trying to reference to. So in this case, the circles, and then how long that hole is in the center. That circle with the, looks like a Twinkie in the middle, is basically just a circle. It's a sized object. So whenever you're talking about size, you're talking about the dimension of a specific feature, the size of a feature. Okay? How tall something is, how long it is, how big it is, how small it is, whatever. The location is referencing usually to an edge. So where is this circle at in space? Where is it at in orientation to this square? Basically, it's going to be from the top to the center of this square, it's going to be 0.61. And from the side to the, to the center of this circle, it's going to be 0.71. Okay? So the location dimensions are identifying just where it's at in space, and the size is identifying how big it is, how small it is, how long it is, how short it is. That's one of my 60 bosses, yeah. I know, it's crazy, right? Not just like trying to play Fortnite or something. Yeah, right, in Call of Duty. Yeah. What you doing today, Rob? Nothing? Nothing at all. I got that on recording. We're all set. All right, chain dimensioning. Let's talk about this. Instead of talking about it, let's just show you. So there's two different types of methods inside of chain dimensioning. The first one is just literally like linking chains together, okay? You're going from the left to the right, chain, 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 link, link, link. The one on the, still method one, but the right side of that is going from the top to the bottom, chain, chain, chain. Method two is still chain dimensioning, but the difference is that you are doing an overall length and an overall height. Why would we do that? Because eventually when you get to a little bit more complex in actual engineering, you do not want to sit here and try and do this math. This is really easy, right? But some of these are going to have, you're going to have millions of tolerances. Like, you do not want to do all that math to try and figure out what the overall length or the overall height of an object is. So they use this, and that's why it says preferable chain dimensioning method, is because it's just easier if you have it right plain out there. Okay? So chain dimensioning, linking, 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 and then the very end, you just do overall. Datum, this is what you guys know how to do. This is what we've already done. This is what I've trained you to do at the beginning. You have a 0, 0, okay? You basically have a point of interest that you're going to start with, and then you are going to basically go up and then go back to that point, go to the next edge, go back to that point, go back to the next edge. Same thing here. You're going to start at a point, you go to the edge, you go to one point, back to that point, back to the edge, whatever the case may be. Sorry. And that is datum dimensioning. Datum is just like an origin that you have. Any questions so far? Am I going too fast? Good. Okay.
Mr. Cupid.
Yes.
You told me that I smell good. I feel
Cool.
comfortable.
Cool. Dimensioning symbols. These you're just going to reference to later. This is just like a database. I'm not going to sit here and waste my time and go through that because I'm going to talk about most of them. Here's the next step. So coordinate and angular. Coordinate method, and I'm just going to show you down here. Coordinate method is using points that basically coordinate where this angle is at. Coordinate method and angular method just talk about angles in general. So if you look at the bottom left one, it's coordinate method. They basically identified this dimension, and they identified this dimension, and then they just connect the dots. They didn't even measure the angle. In the angular method, they actually measure the angle. So they still reference to one of the points, but then they just measure the angle itself. They are, because it's mandatory there. There's no other way you could do that. Unless, remember, you can't break one rule to get to another through another rule. So you don't want to go on the part, right? So they're going to ask you, I guarantee they're going to show you a picture. Which one, which angular dimensioning style is this, or method is this, coordinate or angular? If it shows an angle, it's angular. If it doesn't, it's coordinate. If you're connecting the dots, it's coordinate. Okay? Okay, next. Chamfers. So chamfers are something brand new. We didn't talk about this yet. We haven't gone into this yet. Basically, the best way I can describe a chamfer is a lazy fillet. Okay? It is a flat fillet. It's a flat fillet. And all it does is it's a lot easier to machine a chamfer than it is to do a fillet. A fillet, you have to figure out a radius, and then you have to basically take a chamfering or a radius or a fillet tool and actually cut away material. Now, when you're doing steel or really hard stuff, it's really expensive. You need diamond-tipped blades or diamond-tipped systems to do that. It's too much. So with chamfering, in this case, all they got to do is take one solid blade and go across the edge of a part. Why do they do it in this top one? Well, it shows here two options. You can basically, the only reason you do this is just to get remove of a sharp edge, right? But at the same time, there's two ways of actually dimensioning them. The first way you can do it is using the angular method by just saying that you have 45 degrees and one of these heights is 0.125. Okay? Or, big or, you can do 0.125 and 0.125 over. And that is the coordinate method. Same exact thing, same exact information, just a different way of doing it. There's multiple chamfers. There's an external chamfer, which is basically just the outside of a part. There's an external chamfer inside of a part, which kind of freaks a lot of people out. But basically, this is the end of a bolt. Okay? This part shows the end of a bolt, and it basically, the reason they have them is so that you can easily align into a hole. Now, if you have a bolt that's really small, not a screw, a bolt that's really tiny, and you're trying to put it in a tinier hole, it's really hard to align them. It's really hard to make them fit. So they use these chamfers to basically auto-drop those pieces in. They're easier to get into. And the last one is internal chamfers. And those are basically used with countersink or counter bores. And what they do is they just have an outside flange instead of an inside flange. Flange. It's flange.
Is that
It's an actual term.
so a chamfer is basically just a flat fillet?
Yes.
You like fillet?
I like mignon. So this one is saying, again, the angular method with the distance. Okay, arcs and circles. What do you dimension with a arc? Do you mention radius or diameter?
Radius.
What do you do with a circle?
Diameter.
So this is all literally review. All stuff you guys have already done is just talking about radiuses. This one's talking about, this one's new. This one is silly, but you're going to have to know this for the test. The outside fillet, if it's on the outside of a part, it's called a round. If it's on the inside, it's called a fillet. Why? They just do it.
Why can't it just be fillet?
Because it's, I don't know, I can't say, recording, I can't say why.
Do you like fillet agnon?
So the round is on the outside, the inside diameter, or the inside radius ones are the fillets. What's up, Alex?
Isn't that offensive to Jimmy John's workers? Said it takes a
So dimensioning circles, we talked about this before. This is the diameter of an object. So the arcs or the curves, 3-point arcs, all that kind of stuff, those are radiuses. These are full circles. So when you have a full circle, you have diameter. You use diameter to identify those things. We've talked about this before. Nothing new. This is a new way of dimensioning diameters as well. You don't have to do it. I told you before, you have to do it from the center where the circle is actually facing you. You don't have to do that way anymore. You can use, and is this unidirectional or is this aligned? Unidirectional, good. So this one is unidirectional. You can use unidirectional now dimensions to identify all the diameters for that circle. Nothing really new, it's just showing you can do a different way. This is the last kind of new stuff. You guys were asking, how do I dimension like sculpts, any kind of curved objects and all that kind of stuff, right? In the real world, they do it a lot more scientifically than this, but this is a way of doing it. What they do is they basically just take segments and little increments, increment, and little points along a curve, and they measure them out so that then you can just connect the dots, connect the dot, and get it as close as possible. It's called splines and curves. They say to do it this way. This is not the correct way to do it, but they'll ask you. This one's cool. This is a multiplier. Remember when you had to sit there and try and, like, I don't know, dimension 15 holes that were exactly the same? It's kind of silly. So what they do is they say, it's called a time factor. It's a multiplier. Basically, they take 2 times indicates how many times this is actually inside of the feature. So in this specific case, they have this is a 0.25 diameter through hole, which means the inside diameter is going to be 0.25. It goes through the whole entire part. This symbol means it's a counter bore, which means this drops in, and that makes this outside part 0.38 of the diameter. And that only goes 0.25 down. We'll talk about that all later. All you need to take away from this PowerPoint or this part is that this means that these are two of the same pieces. Dose. And the last slide is pretty cool, I think, because it's a different way of looking at dimensioning. This is called dimensioning radial patterns. So a lot of you guys want to instantly take actual lines and start dimensioning out, like from this circle to this circle, and then from this circle to this circle, lines. Well, you don't have to do it that way. You can literally take geometry, basic geometry, and understand that if I pull out a circle, the center of all these are the same. If I pull out another circle, the center of this outside will always be the same no matter what angle I'm at. Okay? So if you have quadrant 1, quadrant 2, quadrant 3, quadrant 4, you can just identify through radiuses, diameters, and angles where the location of these circles are going to be, rather than just have to try and figure out distances. Just a cool way of doing it, that's all. Okay? So let's go over this one more time. Now that you just learned everything, you're going to go back to 7.1. You're going to draw this thing, right? And then you're going to use datum dimensioning to dimension the whole entire thing. You're going to have an isometric, you're going to have a top view, you're going to have a front view, and you're going to have a side view. You're going to dimension using the rules that you've already learned, as well as the new stuff. Datum dimensioning with aligned dimensioning. Aligned, you're going to have to use ISO. All this information I have already put, because I'm a nice guy, inside of this. So I show you right here, it says if you want to use aligned dimensioning, you need to change it to ISO. If you want to use unidirectional dimensioning, use ASME. 1 to 5 dimensions in a multi-view, front, top, side. Save the PDF of each one of these and put them in there. Now, go back. Datum and aligned. Next one. Chain dimensioning and unidirectional, so ANSME. Coordinate method and datum dimensioning. Angular method, so this way we're going to actually measure the angles. In this one, we're actually just going to measure where the points are at so we can connect the dots. 5, there's reference, so basically it's just referencing that these 3 circles are exactly the same. And then the last one, you're just going to draw and put it into a drawing file. All 5 or 6 of those drawing files, PDFs, just need to be submitted inside of there. Okay? You're going to have all day, the rest of the day to do it, excuse me. And then Monday to work all day when I'm not here. Okay? Go ahead.
If we already have those.
Yeah, a lot of these guys, you should have all these drawings already done actually from a while ago, the very first couple weeks that we were in Fusion. If you do, be my guest. Use what you have, and then just use the drawing files. It'll make it 10 times easier on you. Okay? Any questions before I stop?
Wait, we should have these done.